optimized coating materials preventing rust on common iron nails. Keep in mind all the slide and figures were created by the researcher. The purpose of this experiment is to find a cost-effective coating that can be found in most common households that can replace stainless steel or other more expensive methods in preventing rust. The experiment tested the usefulness of oil and grease in accomplishing this. The background information describes the elements that affect rusting, such as moisture and the air, and the methods to prevent rust, such as galvanization, stainless steel, coatings, etc. It also describes why grease and oil are possible anti-rust solutions because of both of them being hydrophobic and dense enough to not allow air and water to pass through them. My hypothesis is that if the iron nail is covered by a mixture of greases and oils, then the iron nail will resist rusting just as much as other relatively more expensive methods such as galvanized and stainless steel nails, due to their dense and hydrophobic properties. The independent variable are the nail coatings, and the dependent variables is the rate of rust of the nails. The control will be the common iron nail with no coating. The data collection method is to set 7 different nail groups with different coatings, one with no coatings, one with WD-40 anti-rust product, one with stainless steel, one with oil, one with grease, and one with oil and grease mixed. And finally, one with galvanization, zinc coatings. Second, I have 7 different nails in each group, and I measure the weight of the nails at the time intervals that you see here, for a total of around 14 days. Data collection. As you can see from the graph, it displays the trend line of average mass of the 7 iron nails with no coating at each time interval. This group of nails acts as the control. As you can see from the slide and the graph, it shows the slope and how accurate the trend line is. Here's my graph for stainless steel nails. Here's my graph for WD-40 coated iron nails. Here is my graph for oil coated iron nails. Here's my graph for grease coatings. Here's my graph for oil and grease coatings. And finally, here's my graph for zinc coatings. Data analysis. The table above shows the average weight of each of the 7 groups, including the standard error of the mean. The standard error of the mean is mostly attributed to the discrepancies of the weights at the start, the initial weight of the nails. Although the standard error of mean is relatively high, you can see from the trend lines that the data is accurate and relatively reliable. This table shows the slope of the graphs in figures 1 to 7. This slope represents the average rate of rust for each nail. The heavier the nails are, it means the more rusting process occurred. Because the nails absorbed the weight of the oxygen, the lower the slope, the more effective the coatings were. Conclusion. As you can see, my hypothesis was accepted because according to the data, the coatings that had best to worst effects were, first, galvanized nails for zinc coatings, second, oil and grease coated nails, third, oil coating nails which tied with stainless steel nails, fifth, grease coated nails, sixth, WD-40 coated nails, and seventh, common iron nails with no coatings. This data supports my hypothesis that oil and grease can be possible solutions or replacements to more expensive methods, as they are more common around the household and they are easier to obtain. Although galvanized nails seem to be more effective than oil and grease, oil and grease is still almost less than half the rate of the oil and grease coated nails. The rate that they rust is almost half of the oil coated nails. Not the oil coated nails, sorry. Of the stainless steel nails. This still makes it a more possible solution. Thank you for listening to my presentation on